Hello and welcome. In this video, I'm gonna talk about the series, which is minus 1 to the power of n over n, which this series is converge. But why? It's from 1 to infinity. Okay, it is converge. Now, to solve this problem, we want to use the alternating series test. What is the alternating series test? Let's recall it or remind it just a little bit. Now, it's if you have a series like this, and let's change the color. If you have a series like this, minus 1 to the power of n times b sub n, okay, with 1. b sub n is monotonically decreasing, i.e., when we go toward infinity in the index n, b sub n is going downward. Okay, if it's for negative, it's be a negative. If it is a positive, then it's going to be 0. Okay, and not just this. You heard me right, that if it's negative, i.e. Let's say about negative 1 to the power of n, and not this actually, negative n. If b sub n is equal to minus n, then as n goes to infinity, as n approaches infinity or go toward infinity, this b sub n decreasing. Why? Since minus n plus 1, which is this, is less than minus n for every n in the natural number. Okay, so okay, but this, it's diverge. If this is just the case, then we will have a problem where it will be in the theorem that says that if the sum of x sub n converges, then x sub n, the limit of x sub n, will be 0. Okay, now so we have to add another condition for it to be true. That condition will be the limit of b sub n must be 0. Okay, the limit of b sub n must be 0. So it's restricted from being going toward minus infinity, I said about b sub n, or going to the infinity. So it's going to act like this. Okay, so this is the alternating series test. Let's use it in our problem, and you might notice that let's return to yellow, and you might notice that the sum of 1 over n is diverged because the harmonic because it's a harmonic series. It is a very famous series and physics, I guess. But if we add minus 1 to the power of n with it, or multiply with it, then it will be converged. But why? Since we use the alternating series test, which is have two conditions in the b sub n that with it, that taken with it, which have two things. Firstly, it is monotonically decreasing. The second, B7 must be going to 0 as the index going to 0. I think there is a problem here, but I want to check it for later video. But for now, let's just focus on the positive sign. Now, P sub n here is equal to 1 over n, okay? As n approaches or go toward infinity, B sub n going to 0. Not just that, B sub n is monotonically what? Decreasing. So the actual sum is converged. But the bad thing of this test is doesn't give me the value of the convergence. It just gives me the convergence condition, or the convergence, or the convergency of an series, whether it's converge or diverge. Just so because we have two conditions, two satisfied, one is satisfied. So by the alternating series test, the sum of 1 over n to the power of n over n as n approaches from 1 to infinity is actually converge. Okay, so bye-bye. This is the first video that I am presenting in English language. So